Okay. All right. So just going through kind of the introduction of why we need calculus. So right now we should all have a notebook out, pencil, taking notes, because this is what you're going to use to help you get through the lesson. Okay. So rates of change. If I give you this function here, just all right. So what's that? The graph of 4x minus x squared. What's that?
Quadratic going down.
Parabola that opens down. That's right. We've got a parabola that opens down. Can you graph this pretty easily?
Hope so.
All right. How?
Find the vertex.
Can do it a little quicker than we'll need the vertex, but there's a quicker way to know where the vertex is. So if you factor it, what factors out? If I want to factor this, what's the common factor? X. I'm left with 4 minus x. And if you set it equal to 0 and solve each of these, what do you get? X is 0. 4 minus x is 0. So to solve this one, you get x equals what?
0.
4. So 0 and 4 are the what? Intercepts. So now that you have the intercepts, 0 and 4, now you know where the vertex is. So where does the vertex have to be if those are the x-intercepts? At 2. So you know it's somewhere there. Now next question is it above or below the x-axis? Above. How do you know that?
Because it's opening down.
Open and down. So I'll plug into here to get the vertex. So if I want the vertex, I'll just do f of 2. We get 4 times 2 minus 2 squared, so we get 4. So 2, 4 is the vertex, and you can see, we're just going to focus on this part of the parabola, okay? And that could represent something. That could represent the path of a projectile. If that horizontal axis was time and maybe the vertical axis was height, okay? So it could represent something. We're not having it. We're not having it represent anything right now. Okay. So now some questions about that you could answer with pre-cal. So notice that the interval is from 0 to 4. So I could ask you to maybe find some information, like for instance, if I wanted you to find the y value when x is 3. So if I said, can you find f of 3? What's the answer to that? Can you find f of 3? Well, first of all, what is that asking for? The y value on the graph of f when x is 3. That's exactly what it's asking. It's asking what's the y value on the graph of f, this is your graph, when x is 3. So it's asking for this y value here. So how do you find it? Now how do you do it? You just do what? Plug a 3. Go ahead. Take 2 seconds. What do you get? 3. 4 times 3 minus 3 squared. That's 12 minus 9. You get 3. All right. So that's, again, I want to make sure that we're clear. Everything that we're looking at, we would have studied this in algebra, correct? That's what you would have had up until now. Now, rate of change is something that I know my guys last year in pre-cal, we studied it. We did average rate of change. So if we want to find the rate of change, so in terms of a car, the way we kind of talking about it with a car real quick is this. Here's the analogy with a car. If I get on the interstate right here at Salem Highway, what mile marker is that? Do you know? It's mile marker 80. Okay, so let's just say at time 0, we're at mile 80. All right. And then it takes me 1.5 hours and I get to mile marker 178, which is like downtown Chattanooga. All right. So my question is this: do you think from mile marker 80 to mile marker 178, I traveled the same speed the whole time? Very unlikely, unless I was just lucky to get on cruise control and keep it on cruise. But even if I get on the interstate, it's going to take me a little bit to get up to a certain speed. So no matter what my speed was at different points in the trip, I still had to have the same average speed. Because on average, I have an average speed if I was able to coast the whole way or able to cruise. If it takes an hour and a half to get there and you cover this distance, you have an average speed that would calculate on average how fast you're going. Doesn't mean you were going exactly that speed the whole time. Okay, so how do you find that? So to get rate of change, the average, so if we want the average rate of change, all you do is you do your change in position over your change in time. So the word change in mathematics means you need to do what operation? Change in mathematics means you need to do what operation? Subtract. Change means subtract. So change in position. I ended up where? I started where? So we're figuring out how did your position change? How far did you go? Well, how do you get 98 from 178 and 80? You got to do what? Subtract. So we do 178 minus 80 over change in time. How long was I on the trip? Hour and a half, but 1.5 minus 0. And that should give me my average speed. So if we did 98 miles over 1.5 hours, go ahead and do the math there and see what you get. Yeah, that's fine. Just quickly can crank it out.
65.33.
All right. And that's really, actually, that's not surprising. You may say, well, the speed limit on the interstate is 70. I can tell you anybody that's ever gone to Chattanooga knows you can't go 70 the whole way. What do you have between here and Chattanooga? Traffic. What else geographical? A mountain that you must go over. And you have to go up it slowly and maybe come down it slowly, and there's traffic on the mountain. So that probably makes sense. Okay. So right now, my point of this is kind of a review lesson. Nothing we are doing right now is something that you cannot do with algebra or like what we studied in pre-calculus. So you can find average rate of change of anything. You just need to do change in, basically the position is your y and the time could be your x. Change in your dependent variable over change in your independent variable. That will always give you the average rate of change. So what I want to do for our little graph is I want to find the average rate of change. So on this one, it would be the average rate of change. Maybe this could be time, but we're going to call it x. And that could be our height, but we're going to call it y. So we're going to find the average rate of change here from 0 to 3. So here's the question. So for this, find the average Here, let me do this since we've done this example here. Good thing is this will be on film, so you can always go back and replay it. All right. So for this picture, for this figure that we have, we're going to find the average rate of change from x is 0 to x is 3. So now I'm giving you the x's. So remember, average rate of change, we said is change in y over change in x. And the delta symbol stands for change in mathematics, okay? And the word change in mathematics means you have to do what? Subtract. Okay, so what have I given you? Yeah, but what in the statement of the problem, what have I given you? This is, don't overthink it. What did I give you in the sentence when I wrote the problem? I gave you the x's. What do you need to figure out? You need the y's. If I give you the x's and then you have an equation, so we're talking about for this graph, so we know of f of x, find the average rate of change. We're talking about for this function, can you get the y's? Yeah. That's why we practiced one earlier. Okay, so go ahead, find your two y's. I don't know how to pause it. Well, then I go back in and click it, and I don't want to do that. Because once I hit stop, it ends the clip. Now I got to clip it. Okay. So symbolically, so from x is 0 to x is 3, we're trying to find the average rate of change. If you plot both of those points, you're going to see this is the first point. Well, what's the y right here? 0. So that's the point 0, 0. Here, this is the point 3 what? We found it earlier. 3, 3. That's the one that you did earlier, right? Is symbolically, if I want to do change in y, what's the symbol for y? On this graph, what symbolizes y? F of x. So the symbol for the second y, the symbol for this y value here is f of 3. Remember, it's the y when x is 3. And then you're going to do minus f of 0. That's the y when x is 0 over 3 minus 0. That's changing y over changing x. Remember function notation that we would have studied in pre-calculus or algebra. There you go. And you evaluate those. So you said f of 3 is 3, f of 0 is 0. So you got 3 minus 0 over 3 minus 0, which is 1. And that's the average rate of change, whatever the units are. Again, my whole point of this lesson is not to teach you this, because we've already done it, is to review it. Is slope something that you would have already done before this class? Yes. This is all nothing new, okay? And I want you to notice geometrically, what is the 1 in terms of the graph over there? What does this 1 stand for? Yeah, connect the two dots, 0 to 3, that's why we're drawing it out. If you connect these dots, and you draw a line there, the slope of this line, does it look like it's about positive 1? Yeah, I mean, my scale is not the best, but yeah, it's at least positive, right? And any line that goes through 2 points on a curve, we call this is called a secant line. So a secant line is a line that goes through 2 points on a curve. In geometry, you would have studied about secant chords. Okay, the chord that is a line that has hits two parts of the circle, okay? So we found the slope of this secant line, all right? So you can say delta y over delta x, or slope is 1, the secant line. Slope of the secant line. Now, and if this was some object following a path, that's maybe its average, right? Its average speed. Maybe it's change in height over change in position or something. Now here's the $60 million question. If I just said, find the rate of change at x equals 1. So what do we say for rate of change? We need how many points do you need? 2. What's the problem with that question? It's only 1. So what I'm asking for, this is what we're saying, is that think about on the car trip, right? We said on average from here to Chattanooga, you average 65 miles an hour. But what if I said right at your 1 hour mark, or after you've been driving for 1 hour, right at 1 hour, what's your speed right at the 1 hour mark? Do we know? Do we have the information to know what our speed was? The only information I've given you is you started your trip at time 0, you ended your trip at time 1.5. It took you went what, 98 miles. So I'm asking, at the 1 hour mark, do you know what the speed is? You don't. You don't have the information. But is there a speed of the car at the 1 hour mark? Is the car traveling, do you think? Yes, there is a speed. So here's the question that I have. Notice that rate of change correlates to the slope on the graph. The slope between these 2 points is the average rate of change. So if I said at x equals to 1, which is here, that's like right there. Can I find a slope? Well, the problem is, what do I need for slope? 2 points. But you can draw a slope on to a curve. You can draw a line to a curve. You can draw a line that touches just at 1 point like this. Anybody know what kind of line that is? I mean, it's in the lecture if you already watched the video. What line is that touches at 1 point? Do they not teach you these things in geometry? I guess you don't take geometry anymore, do you? A line that touches 1 point on the circle is called a tangent line. A line that touches 1 point on the curve is called a tangent line. So notice I didn't put average. I said I want to find the rate of change at x equals to 1. What's missing? If I want to do rate of change, what do I need? Change means I got to do what operation? Subtraction. So what's missing? Well, over here, when I did, this whole problem correlates to what basic concept in algebra? All that we're doing on the board breaks down to what's the basic concept? What are we finding? It's day 1 of algebra. What geometrical number are we finding? What's this answer? This is what? Slope. That's it. And in order to find slope, you need what? How do you find slope? Slope. y2 minus y1 over x2 minus x1. What do you need to find slope? 2 points. You need 2 points to find slope. What's the problem with the question I've asked? The question I've posed, what's the problem? I only gave you 1 point. But look at the line. Is there a slope of that line? Does that line have a slope? Yeah. If you were going to guess, what would you guess the slope is? Well, here's this line. Do you know the slope of the secant line? Ivan, what was the slope of the secant line that we found earlier? 1. Looking at that line, steeper or shallower? Yeah. So is it going to be bigger than 1 or less than 1? No. If it's steeper, it's going to be a bigger number. That's what slope tells you. The larger the number, the steeper the line. So it's bigger than 1. Okay? So my question is, for you, what are you going to need in order to get the slope of this line? What do you not have? All right, let's rewind it again. If you want to find slope of a line, what do you need? 2 points. What have I given you right here? 1 point. You have 1 point. If I give you the x, you should automatically know the y is 3. When x is 1, y is 3. I've given you 1 point. What do you need in order to find the slope of that line? A second point. Okay? You don't have it. So the question is, what do I try? Maybe I try the same point twice. All right, let's try it. So if I try the same point, if I want to do slope, if I do f of 1 minus f of 1 over 1 minus 1, what happens? If I just plug the same point in twice to the slope problem. No, you don't get 0. You don't get 1. Can't be 1, that slope is 1. What does the top become? What's f of 1 minus f of 1? What's the same thing subtracted from itself? 0. What's 1 minus 1? That is not 0. That's called an indeterminate form. You study calculus, you might as well make a note of that because we get them all the time. That's why we need calculus. Because we don't have the information to solve for this right now. But we can at least get close. So you can't plug the same point in twice to the slope formula, right? If you try that, it just blows the problem up, okay? So if you wanted to get a good guesstimate of that slope there, you need another what? Point. What if I just pick the point real close to 1? So if I could zoom in and maybe pick an X right close to 1 and make another point there where they're almost touching, but they're real close, would that line there almost be the same as this tangent line? See what I'm saying? Instead of moving all the way over here like this, if I picked another point right next to it and drew a line to those 2 points, would it be about the same as the tangent line? Did you follow what I'm saying? Here, I pick another point right next to this point. Here, right there. There's the 2. If I draw a line through those 2, is it going to be pretty close to that? Yes. What would be a good number to pick right next to 1 to the right? 1.1. So now we're going back to pre-cal. So maybe I said find the rate of change at 1. Well, if I did 1 and maybe 1.1, I should be able to do it now. And let's go ahead. So now you can use your calculator, use those 2 points. So you're going to do f of, fill in the blank. What goes in each blank? What goes here? F of what? 1.1 minus f of what? 1 over 1.1 minus 1. You need a calculator. Go ahead. You guys need to not use phones. You need to bring a calculator to class. If you're going to be in AP Calculus, you need a calculator. You cannot take the AP exam without a calculator. So you need to get out of the habit of using your phone as a calculator, please. Okay, what'd you get? It's got to be right under 3. A little bit less than 3. Or no, I'm sorry, a little bit less than 2. 1.9, that's right. Should be about a little bit under 2. So, you can do this at home. Let's just say you got 1.9 as the slope. That's right, because the actual slope right here is 2 of that pink line, of that tangent line. So what does that mean? If I'm telling you that I know the slope of the pink line is 2, a couple things. Do I have a calculator? Do I have a calculator right now? No, I don't have a calculator. I've told you the slope of the 1 point line. What does that mean? That there is a way to get it. When you have only 1 point, there's a way to get the slope. There's a way to get it. The 2 point line right next to it, right, the 1 to 1.1, she says the slope is 1.9. That would make sense. Because it's a little bit tilted like this. It should be a little bit under 2. And that slope of the tangent line is 2. So the line that has only 1 point on it, I know the slope of it. So this line right here, this tangent line, the slope is 2, this pink one here. So that means there's a way to do it. Guess what you need in order to find the slope of a tangent line? What subject? Calculus. In calculus, you can find the slope of 1 point lines. Lines that have only 1 point on it, we can find the slope of it if we know the curve. From the curve, I'm able to get the slope of that line. Okay? So that's one reason for calculus. So rate of change at 1 point, which is slope of tangent line. You need calculus. Why do I need calculus? Because how many points do you need to get slope? 2. My point was with picking the 1.1 was what? What was the point of picking the 1.1? Even though that's not right, I picked it. Why? It was close. So you at least get it to check our answer. Okay? All right. That's one concept for calculus. So that's one thing we'll be doing in calculus. So let's just say you've got whatever it is. I'll give you another example real quick. I'll just stick with a parabola because it makes it, we can do an x cubed. All right, so let's say you got the x cubed graph. And let's say over here at 2, I want to find the slope, okay? So there's the x cubed graph right here at 2. I want to find the slope. So question again, is it positive or negative? The slope, right, positive, okay? Is it steep or shallow? Steep. So I can tell you from calculus that the slope is 12. So I'm able to get the slope of that line very fast, okay, without much computation. And that's what we'll learn in calculus. Okay? How do you get the slope of a tangent line with only 1 point? See, I only knew 1 point, right? X is 2. I can tell you the slope of that line is 12. Okay. All right, so this will get you started, and you can go into the website and get started on that. The other part of the video that I posted, the other part talks about area. Just find an area of rectangles. So go through that video, and I'll email you the video link. So what I'll email the whole class is, I would not rely on